maybe I'll speak to the engineering team side of it. There's inherently on almost all the products that we touch, or really that any of our clients out there are working on, they're going to be electromechanical. They're going to inherently have hardware, both circuit boards, mechanisms, and there's going to be software, right? At this point, there's hardly a device out there that doesn't have software on it. And so you think about that, how it kind of breaks down disciplines, right? It's going to be computer engineers, computer programmers, electrical engineers, mechanical engineers. Those disciplines are kind of, it's going to be hard to not have those on your team. So I would tell someone, if they were a new, head of R&D at this either startup company or even just coming into existing company, but they're trying to build out that team, looking, do you have those disciplines? Because, unless you're doing just the simplest of a new collection swab or something like that, you're going to need those disciplines there. And then obviously there's definitely supporting kind of engineering disciplines that kind of branch out for those, right? So maybe someone with more of a manufacturing engineering background, obviously that kind of overlaps with the mechanical and electrical side. Someone who's got a lot of good DFM background, maybe a systems engineer who kind of looks over all of those disciplines a little more. They've got enough mechanical, electrical, and process and manufacturing. So, that's another very common role that we see. Sometimes actually kind of maybe one of the most missed roles is having a system engineer. You need someone who's keeping in mind that big picture. So, those are a lot of the roles. And then you're going to have to kind of tailor it a little more to your product. So you kind of take any one of those disciplines and think about how that applies to your product. So if you're an electrical engineer, if you're building out your electrical team, is your product very complex from the power side? Do you need people with really strong backgrounds in kind of power engineering? Maybe your electronics have a strong kind of Bluetooth or RF connection where you need someone that's got a very custom antenna in there. So you want to be looking for people that have that electrical engineering background. On the software side and the programming side, almost all devices now have a mix of software and firmware. You want to make sure the people you're recruiting for and building out bridge that divide. Even if the device is primarily software based, there's likely going to be some embedded firmware, and they need to be able to understand how you communicate well with that. And also, I guess on the programming side now, with everything being so connected to the cloud, you're going to need people who understand how to then take that software, connect it up to the cloud, to the company's other products. I'd say it's particularly important if I was talking to, let's say, the new head of R&D at a large global company. Very good chance that global company already has cloud system where they're communicating with other devices, and so making sure that they bring people on their team that will understand how to mesh that well. So you're gonna want all of these different disciplines, and then also I would say bringing in on engineers who have experience working with assays and understanding some of the important details about how the people on the assay side, what decisions they're making influence the engineering side. So obviously you don't want people who are too green in that regard. Ideally, they've worked with the assay teams before and they understand how important things like temperature control are, or volumetric control on fluid pumping or dispensing, things like that. So I don't know, I guess that maybe that'd be some of my initial advice I'd pass along.
Yeah, Brian, that was great. Yeah, and I think you identified a lot, pretty much every discipline you would need from an engineering perspective on a team to use the phrase from prior key points episodes, automate an assay, right? So the science is typically at the client site. And then I think that's really the question. Like, what team do you need on the engineering side? The question we want to discuss. What team on the engineering side, and arguably, what should you have internal at your company, and what should you rely on externally? I think one area that I think is maybe up for discussion that you didn't mention was microfluidics, right? So a lot of these companies and diagnostic assays require microfluidic control manipulation. Usually microfluidics is like a core technology. So I feel like we're seeing a lot of that expertise on the client side, but I know in the past, you know, teams that are built internal still need external help, particularly on the microfluidics, which I think is the heart of these platforms. So can you speak a little bit to how a team at a client site that has some microfluidic expertise can really leverage external expertise to get their assay, I guess, more robust and the platform more mature?
Yeah, I think that's a great point you bring up. I mean, at this point, almost every device has some kind. Well, almost every device has got fluidics to begin with. I'd say there's a fairly small subset of IVD devices that don't have fluids in them, and then from there, to your point, pretty much everything is moving more and more micro and even nano at times, and that's just for efficiency, throughput. The smaller you can drive down your fluids, right? The smaller and quicker, the faster you can process things. So it's a good point. You definitely want people, both internal and external, on your teams who have good microfluidic backgrounds. There's a mixture of kind of what that might mean. So that may mean you have some people on your team that have really deep analysis skills on microfluidics. So what I mean by that is, someone who has a PhD background where they have done some really complex CFD modeling of how fluids move through a cartridge. That can be really valuable. You can save yourself a lot of time, save a lot of testing time if you can do some really good CFD modeling to understand how is fluid going to move into a small cartridge and make sure it wets out all the surfaces properly, make sure air bubbles leave. And so I think that's a great expertise to potentially have in-house. If you don't, there are, external partners that you can work with. So it doesn't necessarily have to be in-house. And then I would say maybe a step up from, so we're thinking about modeling, we're thinking about very specific flow in a very small localized portion of, let's say, a cartridge or a device. But then there's, as we kind of zoom out, like slightly more macro fluidics, even if we're in the microfluidic land, but where we're talking about now, pumping fluids through a cartridge or an instrument. And that's where you want someone who also, maybe it's a different person, but someone who has experience understanding fluidics from more of a pressure drops across a cartridge or a system, right? If they're going to get good pumping, what pressure losses do you have? How does viscosity play into that? Understanding the different kinds of pumps out there and pumping options. Should you be looking at peristaltic pumps, or should you be doing something more of a syringe pump? So I would say that's someone who's got good fluid experience, but also, understands maybe a lot of the off the shelf equipment out there that's used. And ideally, you internally on your team have some people that are familiar with these things, familiar enough to work well, to the extent you're outsourcing, can interface well with external teams.
Yeah, that's great. Great point, Brian. And so yeah, we're kind of working from the inside out now. And I liked how you described, microfluidic expertise, but then more like systems level fluidics control